Today's video, we're going to talk about the factory method pattern. Let's first think about if we have a web server and we want to render different pages based on the HTTP response code that we get. If we get a 200, it means success, so we're going to show some actual content that we get back. A 404 means that it's not found, so we have to display a fallback page. If it's 503, then the service is down. If it's 511, it means authentication is required. So each of those response codes, we want to render a specific page. If we think about this, we could just do a giant if-else block that does everything. We check the code, we create the right page, we display it, so we could all do this in one place, which is okay. But then later, if we want to add some additional features, such as if we want to add some logging for security instances or compliance, then we know that we only need that in specific response codes, like the 503, 511. We don't do that in the 200 response codes. We're seeing that this creates a problem because everything is sort of becoming more convoluted. It's started to be coupled together. And so the factory method is used to kind of solve this issue that we're already seeing here, which is we're going to let the subclasses decide which class to instantiate. The factory method pattern is a creational pattern that goes alongside the builder pattern, the abstract factory, the prototype, and the singleton. It's defined as an interface for creating an object, but lets the subclasses decide which class to instantiate. This means that the parent class says, I need to produce this product, but it delegates the decision of which product to its subclasses. The key insight is the separation between the using code and the creating code. Your client calls a factory method on the abstract creator. It gets back a product. It never has to know or care which concrete product it receives. So we want to think about what the code looks like without this pattern. If you have one function with a growing conditional, every time you add a new response type, you extend that conditional. Every time you need a side effect of some codes, but not others, like logging only security responses. You add more conditionals inside existing branches. Notice how the function has to call the audit log method inside some branches, but it's not calling it within other branches. That cross-cutting concern is tangled directly into the rendering logic. There's no clean way to test the logging in isolation, and extending to new code always risks breaking existing branches. We're going to look at the structure of the pattern. Here is what we're going to look at. It mimics the demo that I'm going to show later. We have 4 roles in the classic factory method pattern. The first one is abstract creator. It declares the factory method. It says, I will give you a product, but I won't decide which one. After that, we have the concrete creator. It overrides the factory method and returns a specific concrete product. Then we have the abstract products, and that's the interface or abstract class that all the concrete products implement. And finally, we have the concrete product. This is the actual product that's being created. In this repo, those 4 roles map to real Typescript classes. We have the web page generator, that's the abstract creator. It declares the create web page method that creates this content web page response and security web page response. And these are the concrete creators. The web page is the abstract product and declares this display method. And the default web page, content web page, security web page, and service web page, these are the 4 concrete products. There's also this HTTP web response. It's sitting above as a routing layer. All this does is it delegates to one of the 2 subfactories based on the response code. This is a nice extension of the basic pattern. Here we're going to look at the web page generator first. This is the abstract creator, and it lives in the source interface's web page generator Typescript. If you look at here what's missing, there's no new call anywhere. The abstract class just says, whoever extends me must implement this method. They must implement the create web page. The DOM references user content. It also references the user article. These are stored here because all the concrete creators, and by extension, all concrete products need them. This is a good example of sharing infrastructure at the abstract creator level without coupling any specific product. Here we have the web page, and this is the abstract product. It provides two shared helper methods, the display image method and the display article method that writes directly into the DOM. Every concrete page type inherits these, so there's no DOM manipulation duplicated across 4 different classes. The abstract display method at the bottom is what each product type implements differently, what image to show, what article text to render. Here we have the concrete creators. So the first one we have is the content web page response. And it's focused on content type responses. If the code is 404, then we will return a default web page. Otherwise, we return a content web page. 2 lines, there's 2 product types. The class never needs to change unless we add a new content type response code. And the security web page response will handle the 511 and the 503 responses, and it adds something a bit different. The logger method runs before the product is returned. This means that if the code is 511, it logs a security warning. If it's 503, it logs a service error. This side effect, the audit log, is cleanly isolated within specifically the security web page response. The content responses never see it, so our separating the creators is precisely what makes this isolation possible. Going over the concrete products, at a product level, each concrete class has a specific display method implementation. The default web page is what we have for the 404. It shows a hard-coded fallback imagery and never touches the response object at all. For a not found response, we don't trust the response content. If there's a 200 response for the content web page, it renders the response object, the content, and the response article directly. It's the happy path of the product. If we see a security web page for the 511, it shows a stop image and it cannot access regardless of what came in the response. The access is blocked, so the response content is irrelevant. And the service web page, the 503, it renders the response content in the service error contents. So it's similar to the content web page, but created by the service factory, which means that the logging side effect ran first. Looking at this would be the index Typescript that kind of initializes all the code here. The factory hierarchy we see is constructed once and injects the 2 subfactories into the HTTP response factory. Into the HTTP web response. After that, every click call calls just 2 methods, the create web page and the display. The client has no switch statement, there's no if else, no knowledge of the default web page or the security web page. The factory hierarchy handles all of that. So this is what the factory method payoff is. The client is completely decoupled from the concrete types it's using. If tomorrow we add a new web page, such as the rate limit web page for 429 responses, we just add a new creator, a new product, and we can wire it in, and the button click handler never changes. Here we have the factory method pattern demo right here. Looking at the flow at the top, this might be a bit confusing, but we want to think about having two factories. We have the higher level factory, which is the HTTP web response factory that allocates to these lower factories that are more specific, the contact factory and the security factory. Through these factories and subclasses, they actually will generate the appropriate web page depending on what code is being allocated or responding from the HTTP web response. Through that, each of these smaller subclass factories will use the create web page method to generate the specific concrete web page that needs to be generated based on response. So if we look at the 503, it generates this page. The issue is logged. They have this article here. If we go to the 404, we get this page. The content is not found. We have the default page, default article. If we look at this 503, this is logged as well. If we get a 511, we get that this is logged. It cannot connect. We got to stop here. And let me see if I can generate it. And then if everything is fine, we'll get the content here. We'll get an article here that matches with the web page. If that didn't make any sense at this moment, we're just going to look here at the factory that we have. The abstract class, this is the abstract creator where all the factories are being used to appropriate the right web page. At the highest level, we will have these two variables. Here we have the user content, user article. They are the DOM elements. This is going to be passed through all of the subclasses that are within this abstract creator. You can propagate all the way down, and this is important when we look at the other factories. Another important part to look at is this create web page method. And just to highlight, it helps the subclasses determine which concrete web page to create. Going backwards to here and going to the index Typescript, we see these two within the web page, web response. Top level creator, it has these two content web page response, security web page response. These are concrete creators that implement the factory web method to return a specific web page. If we go backwards here to here, we can see that at the highest level, they're all implementing the create web page. From the create web page here at the highest level, we can see that if there is a specific response code that we are given through here, we can either go through here, there's security response, which is going to this factory and going through that factory method on the create web page, or we will go into the content response, which means we'll go to that web page method. And going through more specifically, looking at the content web page response, we see that there's a concrete creator for the content type. If we went in here and we created a web page from the content web page response, we look at the code. If it was a 404 code, we go here and we can generate the concrete product, which ends up being that web page, which is the one that we have when we have no response. So it's like a default. It's a default one. This doesn't change. We have basically one specific article with one specific image, and this becomes the default. This is the hard-coded default fallback, which we use to pull off this display image method and display article here, which falls with this specific image and article. If we go to the content web page response here, this is when we get a successful 200 response. Now from here, we can actually go into the response that we have here, and we're able to get the content and get the article from there. That means that every time we get a 200, there should be a different image and article, all depending on what the content and the article is from that response. So here we can already see that there are nested create web pages that we have here from the higher level, from the higher level to the lower level. Concrete creator factories generating to each one based on the create web page here, that we're using this method to create web page, and we keep propagating down, and this way we can isolate and separate between what specific responses, what we want to do in those specific instances, responses, methods, classes. Since we separated here by security response and content response, we might want to do something like this. Maybe we want to only log when we get a 511 or 503, you know, and we can allocate this on the higher level. Here, we're not specifically adding that conditional only in here. We're able to have two layers of this separation, noting that if it's these specific codes, go and return this, and within this class that also is a creator for the products, make sure to also do a log. And through this pattern, we're able to specifically separate even further. And when we modify and add on to the concurrent creators, because we have this separation, we're able to just only modify, we can modify this specific factory method, the create web page and the security web page response, without having an effect on anything else that's found within the content web page response, in the higher level web page response. We're creating a specific isolation, and vice versa. We could definitely modify in this create web page, and we can even go further at the bottom level, and we can just modify the web pages themselves as well without it affecting all of these other classes. They don't get convoluted anymore. So through that, we can allow the subclasses themselves, as we go down the chain, to decide which one to create, whether it's this one or this one, and we just keep propagating down through this specific method implementation that we have. There are three real-world analogies we can look at to help understand the factory method pattern. We have vehicle rental desks. Think about you walk up and request a vehicle for a specific trip type. Maybe you're going on a city tour, a mountain road trip, or even like delivering cargo or moving. The desk, which we can think about as the factory, hands you the right vehicle type. You drive it using the same interface. It's just steering wheel, accelerator, brakes. You don't know what the booking system did internally. You just get the car. There's another example, like pizza franchises. Every franchise follows the same preparation process. You prepare, bake, box. But a New York franchise makes thin crust. Maybe a Chicago franchise makes dip dish. The abstract process is the same, the concrete product is different. And the Chicago franchise might add extra quality control steps. There might be some logging, auditing that the New York franchise wouldn't do. If we look at logger factories, that's another good example. So if we look at the logger factory get logger method, it always returns a logger interface. But whether you get a file logger, console logger, or network logger, it depends on the runtime factory configurations. The calling code is identical in all three cases. If we compare the abstract factory with other different patterns, there's two patterns that can come up with the factory method. We have the abstract factory. And this one is the scaled up version. The factory method, it creates only one product type via one factory method. The abstract factory will create a family of coordinated product types via multiple factory methods. If you extended this demo so each response type also created a coordinated notification banner and a status icon, all from the same factory, then that would be the abstract factory territory. This repo has an abstract factory pattern that shows this in action with the coordinated UI theme. Also thinking about the builder, that's another one that can be confused with the factory method. This is a different pattern entirely. The builder constructs a complex object step by step, often with a fluent interface of setter calls. It's about configuring how to build something. Factory method is about choosing which type to build based on a condition. If your HTTP response objects need a complex configuration, such as auth tokens, retry policies, custom headers, you might chain a builder onto the factory method output. They're complementary, they're not alternative. The factory method in summary gives you a clean way to delegate object creation to specialized subclasses. It's keeping each creator focused on its own category of products. In this repo, a single button click travels through the HTTP web response, then it routes to the right subfactory, and then it returns the appropriate web page. It does all this without the client knowing or caring which concrete type it receives. The pattern pays dividends. We need to add new response types without touching existing code. When different creators need different side effects like logging, and when you want each creator to be independently testable. The next step is the abstract factory pattern. If you're following through with this, videos and everything like that, which is also in this repo, it shows you how the factory method scales up to creating coordinated families of products. There should be already a video covering that pattern already with an example as well. If you enjoyed this video, I'd say try and add a new HTTP page with the response like a 429, like a too many requests creator and product. You can go in and you can look into the code and extend it out. Thank you for watching. I appreciate it. If you could like it, subscribe, add a comment. I would appreciate it. And I will definitely see you next time. Thank you.